This is the vernier charge sensor. It can be used for electrostatics labs, both qualitative and quantitative. And so right now, I've already hooked up my charge sensor to my LabQuest 2. And what I'm going to do is just investigate some charging by friction on my body. So we'll do an experiment where I'm going to scuff my feet on the floor to generate charge on my body, and then I will actually be measuring that, and we'll see some numbers appear on the LabQuest as we do this. So to do this, I've already got it all set up, and I'm going to go ahead and scuff my feet, and I'm going to hold my finger down inside this Faraday pail, and we'll see some numbers appearing there. If I pull it out, it changes. If I go back, it goes back again. So we're actually seeing some numbers associated with me being charged and the charge sensor is actually being able to measure that. We're now going to use the charge sensor to investigate separation of charges by friction. And I'm going to use these two pieces of the electrostatics kit. And what happens is I rub these against each other. One becomes positively charged, one negatively charged. And so it's kind of like me scuffing my feet on the floor. I can rub those together here. So I'm going to be using that. Let me talk a little bit about how I have this wired. What I've done here is this part of this metal piece here is what we call a ground plane. And it's actually attached to this cage via the wire here. And the wire from the charge sensor is also attached there, the black wire. And all of that is at ground potential, so it's all grounded at the sensor. And the other wire from the charge sensor is attached to the inside pail here, the Faraday pail, and attached to the red lead. So the idea is that this cage and plane are at a different potential from the inside pail. Now, one of the things that can happen with this charge sensor, and we've seen this with me scuffing my feet on the floor, was that I can become charged. And what I might want to do is to keep my body from becoming charged by using this wrist strap that comes with the electrostatics kit. So what I'm doing is attaching it to me, and then I am attaching myself to the ground plane so that I'm grounded in reference to that pail, so that I don't inadvertently charge things that I don't intend to. Need to set up the LabQuest, and I'm just going to leave the default time setting for this experiment, which would be 10 samples per second for 60 seconds. So that's fine, but I do need to make one change. I would like to do what's called a data mark and enable that. And what a data mark allows me to do is actually mark points on a graph and be able to describe what it is that I'm seeing on that part of the graph. So all I did was enable that. And now we're ready to go. So what I will do is start data collection, then rub the charge separators together, and then I'm going to stick the white one into the Faraday pail, and we watch the graph change there. And so I'm going to hit mark and mark that point. Now I will remove the white one, and now I'm going to stick in the gray one. And we see the graph go down there, and so I will mark that one as a mark, and then I'll pull that one out. And now I'm going to very carefully put them in together without touching them together or the sides of the Faraday pail, and so they're in there together.
I'll have my lab partner mark the point.
And now I will pull them out, and let's hit stop. So now we would take a look at the actual graph here. And so the first part was where the white one was, and there's the gray one, and there's the ones together. Now what I like to do is actually label my marks to say that. And so I'm going to come up here where it says data marks, and I'll tap there, and it gives me the list of the various marks. I know that that first mark was the white one. And the second one was the gray one. And the third one is, I'll just call both in there simultaneously. So I'll say OK. So let's take a look at some of the values there. And if I see there that I've got a charge, the white one, 2.81 for that particular point, I will scale down here. I get negative 237. It's within the same range, so I would hope that they would be equal and opposite. But as time elapses, we do get a little bleeding there of charge away. So, but I'm getting basically a positive and a negative charge. And then when I put both of them in there together, they essentially cancel each other out, and it stays basically at 0 that we had before. So we've seen in this usage charge separation, using the charge separators by friction. So I've charged it and being able to measure that charge with the charge sensor.